Black holes can be one of the most fascinating and mysterious phenomena in the universe. They are animals of immense strength, but at the same time almost invisible to us. Imagine a black hole weighing perhaps 2 to 4 million times the mass of the Sun. Thanks to intensive research over the last few decades, we have gone from being absolutely ignorant to learning more and more personally about them. And things only got worse. NASA just announced that we finally got a glimpse of what's inside a black hole. This new information sheds light on details that the scientific world may have overlooked all along. Join us as we delve into black holes and reveal what's inside. Before we get into the details of NASA's discovery, we need to talk about a few things first. Although most of us have some idea of what black holes are, there are still gaps in our actual knowledge. In 1916, Albert Einstein published his general theory of relativity, which predicted the existence of black holes. At the time, the concept of black holes was purely theoretical. It took another 50 years before the scientific community found evidence for the existence of black holes. In the 1960s, scientists were studying the Cygnus constellation when they noticed a strange bright blue star emitting X-rays. This star was not a stationary object, but orbited a gigantic black matter. Further investigation found that a black object orbiting them absorbed X-rays, hence the name black hole. This discovery was significant because it proved that black holes exist and were not just a figment of Albert Einstein's wild imagination. But this discovery also meant that there was this unreal entity in space that we desperately needed to learn more about. Scientists from all over the world got to work. The black hole called Cygnus X-1 is located about 6,000 light-years from Earth in the constellation Cygnus. And this was no small find. It is approximately 14 times the mass of the Sun and incredibly dense, giving it a strong gravitational pull. Gravity is so strong that even light cannot escape it. That's why it's called a black hole. The concept of a black hole is both fascinating and terrifying. This is a region of space where gravity is so strong that nothing, not even light, can escape. Anything that gets too close to a black hole is pulled into it, never to be seen again. But this aspect of danger makes it all the more necessary to learn all that can be known about them. Is that it, or are we just getting started? The answer was ultimately the latter. After the discovery of Cygnus X-1, scientists began searching for other black holes. They found that there could be almost over 100 million black holes in the Milky Way alone, but because they are so incredibly difficult to detect, we still don't have an exact number. However, there are several million black holes in the Milky Way, right in our galaxy, which makes their study even more important. So, let's break it down. The main concern of black holes is always gravity. Their attraction is so strong that everything that enters it is astronomically compressed until it becomes a singularity. Simply put, black holes are like cosmic vacuum cleaners that suck up everything. One of the scariest aspects of studying black holes is that if someone fell into them, they would stretch so far that they would become a single line. This process would be slow, and the person would die before the final form actually developed. Let's just say no one gets into it. But they are over, so can we really be in danger? Despite being 500,1000 light-years away, the closest black hole to Earth is still close enough to raise questions and concerns. In 2021, scientists were able to publish the first clear photo of a black hole, specifically black hole M87. This black hole was photographed several nights in a row, and with each photo, scientists collected more and more evidence about it. They had to stitch the individual photos together to create something that filled in all the gaps. That's how they found out that a black hole has 3 layers. It is not just another gaping hole in the void as many people believe. Things are much more complicated. To even get to the empty part of a black hole, you have to go through the first 2 layers. The first layer is called the event horizon, which is the point of no return. Once you pass the event horizon, there is no going back and you are sucked into a black hole. The second layer is the photonosphere, which is the region where light orbits the black hole. Any light that reaches this region is captured and cannot escape the black hole's gravitational pull. Finally, we come to the third layer, which is the singular. Here, anything that enters a black hole is pushed astronomically down until it becomes a singularity. A singularity is a point in spacetime where the laws of physics as we know them break down, and we cannot predict what will happen next. At the singularity, The density is infinite and the laws of physics as we know them cease to exist. Now, what makes this infinitely worse is that each black hole you explore is completely different from the last. Of course, they tend to follow the same three-layer concept, but the way they work can be very different. If it were something else, we just have to jump into those telescopes and study the problem in detail. But you can't do that with black holes. Scientists can only study black holes by indirectly observing the radiation they emit and the gas and dust that surround them. Sending a probe like Voyager into a black hole is not possible because everything that enters the event horizon is pulled towards the singularity, where it is compressed into an infinitesimally small point. So you can't waste billions of dollars just to catch a glimpse every time, because if the probe gets close enough, it will just shatter into nothingness. Because of this glaring problem, scientists have no choice but to study these objects in 2 dimensions, even though they are actually 3-dimensional phenomena. To complicate matters further, there are also 2 problems. Each black hole is unique, and the laws of physics as we know them break down when we try to explore the interior. This means that traditional research methods are not really suitable for studying black holes. But that doesn't mean scientists haven't been busy. There are many different theories and explanations about black holes, and with each one things get more and more interesting. One of the most compelling theories about the origin of black holes is that they come from collapsed stars. When a star uses up all its fuel, it can no longer produce enough energy to resist the constant gravitational pull. As a result, the star begins to collapse in on itself, becoming smaller and denser. If the star is massive enough, this process can continue until it becomes a singularity. To understand the nature of black holes in depth, NASA scientists turn their attention to the core of galaxy M87. Astronomers have spotted a super-powerful vortex of superhot hydrogen gas spinning at an astonishing 1.2 million miles per hour. The immense force of the spinning puck should have sent it violently flying in all directions, but it didn't. Scientists have concluded that to prevent this, a huge mass must be concentrated in the center of the galaxy. This massive object weighed as much as 2 to 3 billion suns and could only be a black hole. But this is not the only theory about black holes.
In 1963, New Zealand mathematician Roy Kerr used Einstein's gravitational equations to obtain the best description of a rotating black hole. Kerr showed that a rotating black hole collapses not into a point, as previously thought, but into a ring of fire or a thin disk. The disk spins so fast that centrifugal force prevents it from collapsing. That spinning disk of matter is called the ergosphere, and it is the region surrounding the black hole where the laws of physics begin to break down. But the most interesting feature of Kerr's solution was that it predicted the existence of an Einstein-Rosen bridge, also known as a wormhole. It is a theoretical passage through space that connects 2 separate regions of the universe, or even 2 parallel universes. The idea is that if someone fell into a black hole, instead of being blasted into oblivion, they would be sucked through a ring of fire into a tunnel and released into a white hole in a parallel universe. To understand how this works, we have to look at the concept of spacetime in Einstein's theory. Spacetime is the fabric of the universe, and objects with mass deform that fabric, creating a gravitational field that causes other objects to move toward them. Now imagine a sheet of paper representing spacetime. If you put 2 points on paper and draw a line between them, it represents the movement of objects through spacetime. But what if you could fold a piece of paper in half and create a shortcut between 2 points? This is the basic idea of a wormhole. It is a shortcut through spacetime that connects 2 distant points in an instant. Wormholes are not just a science fiction concept. These are actually predictions of general relativity, although no one has ever directly observed it. This is because wormholes are inherently unstable and collapse almost instantly. But the existence of an Einstein-Rosen bridge would mean